Hello and welcome to the AICE Chemistry lecture series. In this video, we're going to start chapter 16 and look at section 16.1. Chapter 16 is on the halogenoalkanes. So again, it's an organic chapter where we're going to look at specific functional groups, which in this case is the halogenoalkane functional group. There are only 4 sections in this chapter. Which is I'll start like always with just what are halogenoalkanes and how do we make them. Then we're going to move on to one of the main reactions of halogenoalkanes, which are nucleophilic substitution reactions. So substitution reactions which use nucleophiles. We're then going to look at the 2 different mechanisms through which nucleophilic substitution reactions can occur, and we'll figure out how to differentiate it between the 2 mechanisms. And finally, we'll look at another type of reaction that halogenoalkanes can undergo, which are elimination reactions. So those are the 4 sections we'll see in this chapter, but let's focus on section 1 and the making of halogenoalkanes. So, in order to talk about halogenoalkanes, we first need to discuss the order of the halogenoalkanes. The order of halogenoalkanes is basically the same as when we looked at the order of carbocations. When we talk about halogenoalkanes, which are also sometimes called alkyl halides, so these 2 words are interchangeable, halogenoalkanes and alkyl halides, we are going to look at one of 3 types of orders for the halogenoalkanes. A primary halogenoalkane, that we see here at the top, has the halogen, in this case we use chlorine as an example, bonded to a carbon that has 2 hydrogens and only 1 other carbon chain. So chloroethane, for example, is a primary halogenoalkane because the carbon that the halogen is attached to only has 1 other carbon attached to it and 2 hydrogens, making it primary. A secondary halogenoalkane has 2 carbons bonded to the carbon that the halogen is bonded to. So in this case, we'll have the halogen, and we're using chlorine as an example here, but it could be any halogen, bonded to a carbon that has 2 other alkyl groups or R groups, carbon chains attached to it. So here we have 2-chloropropane. 2-chloropropane will be an example of a secondary halogenoalkane because the carbon that the halogen, in this case chlorine, is attached to has 2 other alkyl groups or carbon chains attached to it. And then finally, we have tertiary halogenoalkanes, which are attached to a carbon which has nothing but carbon chains attached to it, meaning that that carbon has 3 other carbon chains coming out of it. In this case here, we have 2-methyl or 2-chloro, 2-methyl propane, which will be an example of a tertiary halogenoalkane because the carbon the chlorine is attached to has 1, 2, 3 other carbons attached to it. This is very similar to what we saw earlier with the carbocations and how we refer to the carbocations as either primary, secondary, or tertiary. It's the same thing with the halogenoalkanes. It's with the carbon that the halogen is attached to, how many R groups, how many carbon chains are attached to it. Now, halogenoalkanes are very rare in nature. They're mostly man-made, and they're used a lot in industry because of their reactivity. The main source of a halogenoalkane's reactivity, which we're going to see, and so we play a big part in the later reactions we're going to see, is that halogens have high electronegativities. So all the halogens have high electronegativities, and carbon has low electronegativity. And remember, X here means a halogen. Anytime we see the letter X being used, it usually means a halogen. And then carbon has a low electronegativity. So because of that, a halogen-carbon bond is often polar, with the chlorine, or in this case, or any halogen being partially negative, and the carbon being partially positive. That's always going to be the case. And that's what makes halogenoalkanes so reactive, the polarity between the carbon and the halogen. But we'll see more about this as we go into the different reactions. First, let's talk about how do we create halogenoalkanes. Because like I said, they're very rare in nature and they're mostly man-made, meaning that we need to learn the reactions that make halogenoalkanes. Now, there are three different ways in which we can make halogenoalkanes. And out of these three ways, we have already discussed two of them. In chapter 15, we discussed, in 15.2 specifically, we discussed free radical substitution of alkanes with either chlorine or bromine with UV radiation. That is an example of a reaction that creates halogenoalkanes. Although, if you remember, this is not a very good reaction to use because it can make a lot of different halogenoalkanes and we can't really control the products that we get. So free radical substitution is one way in which we can make halogenoalkanes. Electrophilic addition of alkene with either a halogen or hydrogen halides is another way of making halogenoalkanes. It does not require special conditions. We simply react the alkene with either a halogen or a hydrogen halide. Remember, a halogen will be X2 aqueous, X being the halogen, so Cl2, Br2, I2 aqueous, or a hydrogen halide, which is gonna be HX. And again, this is gonna be aqueous. So hydrogen with a halogen. Now, when we do this, we're going to get two different types of halogenoalkanes. This one, the halogen, is going to give us a dihalogenalkane. Because both of the halogens are added over the double bond, whereas hydrogen halides are going to give us just a regular halogenoalkane. And we discussed both of these reactions in 15.3 when we discuss addition reactions of alkenes. So I will highly encourage you to go back, watch the videos for 15.2 and 15.3, and refresh your memory about these two types of reactions that we already saw dealing with the creation of halogenoalkanes. The other type of reaction that can make halogenoalkanes is a reaction of alcohols, meaning that we have not yet seen this reaction because the alcohol chapter is 17. So in chapter 17.3, we'll look at the reaction of alcohols with either a hydrogen halide or potassium halide plus sulfuric acid or phosphoric acid. That's one reaction that will turn an alcohol into a halogenoalkane. We'll also in 17.3 see the reaction of alcohols with PCl3 and heat, which would also turn it into a chloroalkane. The reaction of alcohols with PCl5, which will turn into a chloroalkane as well. Or the reactions with SOCl2, which would also turn into a chloroalkane. So four of these reactions right here, we're going to look at in 17.3 and discuss the creation of halogenoalkanes with those reactions. But we're not going to do that yet. These are reactions of alcohols. They create halogenoalkanes, but they're reactions of alcohols, so they're not going to be something that we see right now. It's something we'll leave for chapter 17. I do want to say that these three last reactions, the one with PCl3, PCl5, and SOCl5, this specifically create chloroalkanes, halogenoalkanes where the halogen is chlorine, whereas the reaction with HX or KX can be any halogenoalkane. and that will be dependent on whether what this X is, whether that X is Cl, Br, F, or I. But that's it. That's all the reactions. So we already discussed 2 reactions. Again, I will highly recommend you revisit these reactions in the videos for 15.2 or 15.3. And then just know that these are also possibilities, but we'll study these reactions in chapter 17 for creating halogenoalkanes. That's it for this chapter. So just a quick introduction to halogenoalkanes. We'll go into the reactions of halogenoalkanes, specifically substitution reactions, in section 2. I will see you all in that video next time.